Okay, I'm actually gonna steal like a couple of minutes from Roy's time because I think that we should all take a second to acknowledge the work of the organizers and of everyone that made this workshop possible, including all of you. This has been really exciting, really fun, and I want to do it now because then we will all be concerned with going out to lunch. So yeah, let's give a round of applause, especially to the organizers who made this possible. Okay, so now for the prime time slot of the day, closing of the workshop, we'll have Roy answering a question that I have to confess has kept me up a couple of nights. Did Christine let Franklin invent contemporary modeling? So you'll have around 50 minutes. Is that okay?
I'm just going to keep talking until somebody drags me away. So
Okay.
good luck in 50 minutes. We'll see.
Probably hungry, right?
Yeah. I think this will be okay time-wise. So okay, I did want to say something. I was going to say something about thanking all the organizers and everybody who came because this has been really rad. But I do want to reiterate that. Some of you know I had some personal stuff in like a really rough last semester, and at times I was like, do I really have the energy to like go for a week-long, international travel trip in January? And I decided I did, and I'm so glad I did because this has been a really, really awesome conference. Second thing I wanted to say is I wanted to actually put a plug in for Pixie. That was the event that Maureen runs with Brandon Feidelson, because if you remember, I talked yesterday, I talked about my student Becca Costin and her cool HB-based feminist logic thing. And I met Becca when she was still an undergraduate at Pixie, and we got to know each other, and then she came to Minnesota to work with me. So, if you send your talented undergraduates to Pixie, and someday some mediocre logician like me will be talking about their work on slides. Third thing I want to say, because this is not in the slides, I jump right into the logic. And I realized Christine Ladd Franklin actually, no, that's the fourth thing I want to say. The third thing I want to say is, again, a little bit of framing, because as I talked about, like, at least with the volume from the workshop that me and Jessica Gordon-Roth put together, we kind of have four sections, right? There's the historical stuff, the sort of applications-oriented stuff, which is often the kind of stuff, for example, Jillian is doing, what I think of as philosophical logic, feminist philosophical logic. Then there's the feminist philosophy of logic, or just feminist logic, which is like the Plumwood, we're arguing about particular, excluded middle and stuff like that, which we've heard a lot about. And then, of course, the pedagogical stuff, which we've also heard some about. This talk is squarely in the historical tradition, right? It's really just canon recapture, right? So in particular, nothing of the content of the talk is going to be feminist, right? It's a very different kind of talk. It's just a straight logic talk, except it's at this meta level feminist because it's part of we're looking at the historians of the 20th century and saying like, F you messed up. There are all these people back in history, certain kinds of people in particular that you just somehow forgot about, right? And that's a nice way of putting it, as you know. That's the kind of talk it is. And I want to flag that. So it's really a history of logic talk and nothing more, except obviously this meta motivation about why to concentrate on this particular figure, who many of you might not have even heard of. How many people before you saw the announcement of the talk had heard of Christine Ladd Franklin? Okay, 4 people raised their hand, 2 of which probably, maybe not the first time, but heard about it, at least did hear about them at the workshop that we had in Minnesota 6 years ago. Probably the thing I want to say, the fourth thing was about the biographical stuff. Lots of talks started like a huge biographical intro. I'm not going to do that. That stuff's out there. I'll just say a few things. Christine Ladd Franklin was a logician. She studied with Charles Sanders Peirce. Okay, did her PhD with Peirce. Very much a part of the sort of algebraic tradition in logic. That if you know about the history of 19th century logic in particular, there's sort of Frege and Russell and Wittgenstein and that tradition, which probably many of us are more familiar with that stuff. Probably not all of us, but many of us. But then there was this competing tradition that came out of Boole and had people like Schroeder and Jevons, Hugh McCall, who I'm going to mention, Charles Sanders Peirce. And Christine Ladd Franklin was a PhD student with Peirce, had to fight very hard just to get a PhD as a woman, but then nobody would hire her as a philosopher or a logician. So she then actually transferred over to psychology and made really important contributions, in particular to color vision theory in psychology. Yeah, it's really cool stuff. I'm not going to talk about that stuff today, but in effect, it went into a different career because philosophy was just not welcoming enough to her that she could even make a living as a lecturer. Which, given some of the massively cool stuff she did, is really sort of tragic. She was well known for a short period during the late 19th, early 20th century for some stuff she did with Aristotelian logic or extensions of Aristotelian logic. That has been written about now a decent amount, including a paper of mine that's forthcoming that I will mention. That's actually not what I want to concentrate on today, although I will mention it and sort of like really quickly say what she did. Okay, so here's the outline of the talk. I'm going to sketch out Lad Franklin's logic, how it works, give you the rules and some examples. Then I'm going to talk about this really interesting idea that appears, maybe not completely novel, but it's very central to Lad Franklin's understanding of the algebraic tradition and how her logic works. This idea of varying domains. Then I'm going to start, trying to connect this to contemporary modal logic. And what I have in particular is the tradition that we have of axiomatic modal logics that begins roughly with CI Lewis in the sort of 1910s, 1920s. Okay, so what I'm going to do is I'm going to give a translation manual from sort of the axioms as Lewis would have written them into Lad Franklin's logic. And then we're going to see which this. Then we're going to do Lad Franklin's modal logic, which is basically I'm going to prove the Lad Franklin analogs of a bunch of principles that Lewis or later thinkers had in their modal logics. We're going to try to figure it out. By the way, I do not have all of it, right? I've got a bunch of really cool principles that are clearly provable in Lad Franklin's logic. I have no claim that this is the full system. In fact, I'm going to point to one principle that I haven't figured out quite how to use yet to get cool results out of. That's clearly a principle in her logic, so there's more to be done. But the neat thing about Lad Franklin that I can talk about in the question and answer a little bit is that she gives an informal version of something that looks like a semantics for modal logic at the end of her dissertation. I've not at all figured out in any detail how this works, but it may well be that we could sort of, I'll say something else about that in a second, could build a modern semantics based on these ideas and then use that to sort of give a soundness and completeness proof relative to that semantics for some version of her logic, which would be really cool. And the idea that she's got semantics, right? Because she's time-wise, there's probably no communication, but time-wise, she's an exact contemporary of Frank, right? Working in the 1880s, right? And of course, we know, this is a myth, and I've written about this elsewhere, but this idea that Frege had no truck with semantics, it was all just a proof theoretic system of the Bertrick and the Grundgesetz, that's false, but that's a very common traditional view about Frege. So it's kind of striking that we get this discussion that looks like an informal version of what looked like a very modern idea of formal semantics, sort of at the end of her dissertation. So that's later work, but I want to mention it. And then I have some final thoughts. Well, and the note, this is why I said I'll do it, and then maybe not with me. The work in this talk at the moment, this is solo work, but it is both inspired by and intended to be, and et cetera, part of a larger collaborative big project on Lad Franklin's logic that I am working with Yasmin Ozel. But she has not, other than some informal conversations, she has not seen this material in the slides yet. So it's part of that project, but so sort of solo work in a practical sense at the moment. So she may change when she looks at it and tells me which parts are stupid and aren't going in the book. So part one, Lad Franklin's logic. So this is a definition. And one thing about Lad Franklin's numbering is it's strange. She uses number threes 1, 2, 3. Sometimes it's an axiom, sometimes it's a theorem, sometimes it's a prose passage explaining sort of the underlying idea behind something. And that's what's going on with this. This is important. It identifies the identity sign and tells us how it works. And we're going to circle back to this later because this one becomes very important. The sign equals is the sign of equality. A equals B, A equals B. Sorry, it doesn't read very well. A equals B, A equals B means that any logical expression A can be substituted for B or B for A without changing value. So identity gives us intersubstitutivity, but it's the second part we're going to come back to. It is equivalent to the two propositions. There is no A which is not B, and there is no B which is not A. Okay. Notice already A and B, there's no A and B look like predicates. Right now, traditionally in the algebraic tradition, Bull, Jevons, all these people, there's these two different readings of the system. There's the propositional system and the predicate. Sorry, the propositional reading, the predicate reading. That's not going to be the case for lab Frank. We'll see why in a bit. Then we get a bunch of identities. I mean, we can read through those and justify. This is all standard propositional logic. Okay. Concatenation, two symbols next to each other is just and. The plus is or. Actually, since they're predicates, it really should be like intersection and union, if you want to be really technical about it. Infinity is the analog of a truth symbol. It really picks out the entire universe of discourse. Zero, as we'll see on the next slide, is the empty collection, none of the things in the universe of discourse. And if you work through these, they're all sort of like late 19th century style versions of familiar classical principles, right? Like the A is intersected with the not, and the overline is not. I should have mentioned that, that's super important. A intersected with not A is just empty, right? I mean, there are no surprises on this slide. I mean, once you understand the notation to work through. Okay, what else did I want to say about this? 2 and 3 were just the informal descriptions of negation, plus, and concatenation, right? And or not. There's nothing surprising that we need to worry about with those, although we will come back to the identity bit. Then we have these rules, so we all have a whole other list of 1, 2, 3, 4, 5, 6, 7, 8 other principles that basically, if you look at them, these are all just replacing ors with ands with ors, and switching the negations. It's a familiar sort of duality in classical propositional logic. It needs to sort of modernize. That's what's going on. So again, nothing surprising here. Here we get something really interesting. Is that no? I did not skip. I did notice. 11. We're at 12. Here we start to get interesting things. So we get that the things that are not A and B are identical to the things that are A and not B. Union with the things that are not A and B. Union with the things that are not A and not B. Okay. So the things that are not either A and B or A and not B are exactly the things that are not A and B. Union with the things that are not A and not B. All right, so you can work through all of these, but what's interesting is Lab Franklin has this very general recipe, for generating things like this and more complicated. So this is kind of a very actually rich axiom scheme for the propositional system. So here's what you do. Say you have infinitely many class terms, right? Predicates. Finite limit and what she calls the complete development of those is the class term obtained by summing up the 2n distinct class terms of the form alpha 1, alpha 2, alpha 3, where for each alpha, it's either the class term or its negation. Right, notice for 2, that if you just ignore that and make that a plus, that's exactly what we get, just all the different combinations. Sorry. Make that a plus and get rid of that. We've got all the different possibilities of A and not A. So that would be, if it were a plus there, that would be the complete development. Okay. So that's the complete development of 2 class terms A and B. How do we turn that into an axiom? Well, we let that be the complete class development of some collection of terms. Then we just divide that into 2 sublists. They're disjoint sequences such that if you union them, that you get the list of from the complete development. And then you just put one list with pluses on one side negated, and you put the other list on the other side. So because everything has to be, notice this is a complete description of the universe in terms of those terms. So every object is going to be exactly one of these, right? It's either going to be A and B, or A and not B, or A not A and B, or not A and not B. So if it's not in one of these, then it must be in one of these. That's what that expresses. So it gives us these nice axioms for 2 terms, 3 terms, 4 terms that sort of divide everything up and say, well, if it's not in one of these, then it's in one of these. And so you get a bunch of different axioms from that. The do short, if you with nice choices, these shorten the derivations immensely compared to some of the other systems that she was responding to before it even gets to the really interesting parts that I'm going to talk about. So it's actually a very elegant system in some ways by the standards of the algebraic tradition at the time. We also get some pretty familiar looking De Morgan's laws. So the things that are not A and B are exactly the things that are not A, union with the things that are not B, of the versions of De Morgan's. And then we get this long thing that I'm not going to explain, but it's actually a generalization of the 2-term complete development thing. But then it's got these additional P, Q, R, and S, and you can work through that and see it corresponds to a classical topology. Okay, now we get to what she calls the copula. All right, she calls it the copula. The identity is already a copula, but this is the novel addition to the system. So the sign, so the copula are actually two, but they're interdefinable, as I noted at the bottom. The sign, V line, I'm just going to call it V line, that is a negation, by the way, is a wedge, a sign of exclusion. A, V line B is to be read as A is not B, or A is excluded from B. The sign V is an incomplete wedge, sign of incomplete exclusion. A, V, B is to be read as A is in part B, or A is not wholly excluded for B. V is made into line V by the addition of the negative sign. What is not wholly excluded from anything is wholly excluded from. A line B and A V line B and A V B are contradictory propositions. Each simply denies the other. So at least in the way I'm going to present this, I'm going in technically, she doesn't say which is primitive and which is the negation of the other, but this seems natural. Is the primitive one is the V. Right, and what that says for two class terms A and B, if you have A, B, B, it's that it's an existential. It's there is something that is A and B. And then A not line B, which is really just not A, B, B, says it's not the case that there is something that's both A and B. In other words, nothing is both A and B. So we get sort of a quantificational thing here. Then we can express all the Aristotelian propositions and then some using these copulas. So some of these are not familiar from Aristotelian logic. A is not B, or no A is B. We just write as A, B line B. A is in part B, or more familiarly, some A is B is just A, B, B, and so on. Right? Notice there are 8 of these, right? It's all the different combinations of either B or B line with either a line or not over A, a line not over B. Right, 2 times 2 times 2 for the choices gives you 8. A little more familiar if we want just to have it nice. These are the 8, well, this should be in big scare quotes, Aristotelian propositions. Some of the confusions that I tried to clear up in the paper that got sent around this morning, this is the one that's just on the non-modal reading of the logic, what had to do with people like not realizing that she was treating all 8 of these propositions and not just the first 4. Which correspond to the, strictly speaking, the Aristotelian propositions in Aristotle. No, sorry. These and these are the Aristotelian ones. Big A upside down, A upside down A, little A upside down little A. Those are the Aristotelian ones. But she, I believe, following Hugh McCall, wanted to extend her analysis of traditional syllogisms to include all 8 propositions. So I'll get back to that in a minute because we haven't seen the theorem that she uses for that, but that's the proposition you get with this connective. And I'm kind of just doing these things in the order they occur in her dissertation, which, by the way, appears in a easily and cheaply purchasable anthology edited by Charles Sanders Peirce, which has a whole bunch of essays, including one by Peirce, which is how her dissertation got published, academic nepotism, which I think is perfectly okay. It might have been difficult for her to publish it otherwise. In this instance. Okay, but now we get some interesting things. We get an explicit definition of her. I'm giving the quote, but trust me, it's explicit. Validity. Right? So if we have a premise P and a conclusion C, validity is just expressed by it's impossible that the premise is true when the conclusion is false. Now, you might wonder about these being premises and conclusions, given that I just said that these are always class terms, they're always predicates, right? Not proposition. We'll come around to that. Trust me on that, and we'll get to that. But that's the definition of validity. We can also express invalidity. It's possible that P and not Q. Right? Oh, this is an exact quote, so I'm going to read it. If P and promise to see a conclusion drawn from it, then P, V line, C line states that the premise and the denial of the conclusion cannot go together, and P, V, Q line states that the premise is sometimes accompanied by the falsity of the conclusion, right? At least once, it's an extension. It is hardly necessary to mention that M is satisfied by either the truth of the conclusion or the falsity of the premise. I think she's being a little sloppy there, given what we're going to say later, but I think that's okay. And that N implies that both the premise and the negative of the conclusion must at some time be true. Okay. But one thing that's interesting about how the copula works in Ladd-Franklin's system is as compared to other kinds of operators for expressing the Aristotelian propositions and doing analysis of syllogism, is the fact that her copula is symmetric, right? The order of the arguments doesn't matter. It's just an inconsistency or a consistency operator, loosely speaking. The word inference or consequence implies proceeding in a definite direction in an argument, from premise to conclusion. Either from premise to conclusion or from the negative of the conclusion to the negative of the premise. But the argument, P, V line C, may be called an inconsistency. This is the fundamental sort of primitive notion in terms of her analysis. She thinks it's best to analyze all logic in terms of analyzing arguments in terms of inconsistency, representing arguments in terms of inconsistency. She thinks is a big advantage. I'm not gonna say I won't go into that too deeply today, but it's a big part of her view. It is an argument into which the idea of succession does not enter, right? It's not that there's a premise and a conclusion that somehow is later than it, right? It's just the inconsistency between two claims. It simply denies the possible coexistence of two propositions. Okay. Then we get some pretty straightforward stuff, some associative identities that are just expressing that symmetry, right? A and B are inconsistent with each other is the same as saying the claim A and B is inconsistent, so on, etc. Right? They're just different ways of saying the same thing. Then we get to some really crucial stuff for what I'm going to do. Yes, real quick.
Yeah, it's because I didn't understand the syntax of having the operator on the right and having it with nothing else on the right.
Think of it as this is just part of it is we're used to saying this is a binary operator, this is a unitary operator.
Yeah.
That's not how these things in the algebraic situation work. It's the best way to like think about it in our terms is it's a binary operator between two sequences of sentences.
That can be empty.
Yeah. Actually, you can always identify it as this. In fact, this is probably a better way. Think of any time there's an empty one on one side that actually the infinity symbol is there.
Okay.
In fact, to be honest, now that's the right answer. She explicitly says that. How I think about it. And it's a binary operator where that's a conjunction, right?
Yeah.
Yeah. So it's a binary operator, but the empty one, it's the infinity symbol. We just don't bother to write it because it doesn't matter.
Is the right also?
Zero. But rarely occurs in the actual computation. We'll see on the next slide it does. But she very much prefers to write things in terms of the infinity because then the infinity can often just be dropped as in this stays here or this stays here. So here's this crucial acting. For instance, informal definition of identity 1 gives us this. A is identical to B is the same claim as, or equivalent to, probably equivalent to us reading. A and not B are impossible, and not A and B are impossible. And if we go back, that's exactly what she says in that last sentence of the identity clause. Right? If the identity is equivalent to two propositions, there is no A which is not B, and there is no B which is not A. Right? Yeah.
I'm sorry. In the slide that you were on, is the identity overloaded? It's always giving me, like with Hugh McCall, it's always giving me a hard time. Like, is that a different identity sign?
It will depend on I think the answer will come in the varying domain stuff. Identity has to be read differently given different underlying domains. So let me come to that, and maybe you can ask it again later. Because there's one reading, in fact, the one I'm going to concentrate on, where it's actually the identity symbol is clearly expressing necessary, coextensionality or equivalence or identity. So combining this with the substitution instance, obtained by uniformly replacing A and B with the negations, do a little rearranging. I will leave it to you. Trust me. Negative A equals B is the same as not A equals not B. That's nice. Then you do a little more less trivial work, and you get this crucial formula. Right? If AB is identical to 0, right? So the class of things that are both A and B is empty. That's the same as saying the class of things that are not A and B is the entire domain. That is identical to saying, and again, here she has the identity explicitly, so I put it, but she commonly drops it, saying that the line holds of A and B. A and B is impossible. Okay. Within the relevant domain, right? There's nothing in the domain that could be both A and B, right? This is crucial because often flipping back and forth between this and the axioms you get for the V line or V and the identities that we already listed, right, is how you derive really cool stuff, right? You rewrite it as identities, you do some substitutions, then you go back and in the other direction, so you get the V's or V bars, and then you can use some of the axioms for that, and we'll see some of those. Here's an interesting rule that she says from phi and phi V bar 0, we can infer phi. Right? Since according to Franklin, for any formula, for any terms A and B, not AB, V bar 0 is a proposition of no content. And she has the A-B line there because that's a particular example she's working through. But the idea is if we have something and 0 is impossible, right, that's trivially true, so we can draw it. Okay, this is the rule that I suspect I can get cool stuff out of, but I haven't figured out how yet. So there may be further principles that aren't in this presentation that I can get using this rule, but I have not used this rule anywhere in anything I've done so far. Okay. More principles, we get non-contradiction, right? A and not A is impossible, we get excluded middle. Failing to be the case that A or not A is impossible. We get some stronger, like V bar versions of the Morgans, which you can work through and they're not too surprising. We also get these interesting dropping terms, right? It's impossible that A or B or C is impossible, but A or B is possible. Again, speaking loosely. ABC is possible and AB is impossible. And again, you could sort of write these out in modern notation. By the way, I'm already slipping into the possible impossible talk where they're strictly speaking, these things we thought of as kind of quantifiers over whatever the underlying domain is. But as we'll see, one of those readings is legitimate possibility and possibility. And then we get theorems 1 and 2, which I think I'm the only person so far who actually bothered to reconstruct Lad Franklin's proofs of these actual theorems, which is like probably my key contribution in the paper that I do have forthcoming. Is noting these are genuine theorems. So the second one, the first one's kind of a dilemma to get the second one. And the second one basically says there's no situation, however you want to put it, where A and B is impossible, C and not B is not in there, is not in the domain or is impossible, but A and C is possible. Okay, the reason this theorem is so important is this gives us the celebrated characterization of the 96 valid syllogisms, right? Now, those of you who studied Aristotelian logic, right, when this is what tipped me off, and I was just reading this for like fun because some friends of mine were working on this, and I hit Lad Franklin saying the 96 valid syllogisms can be derived from this formula, all and only those syllogisms, and can be shown those are the 96 valid ones. And I'm like, I don't remember my ancient logic very well, but I don't remember there being 96 valid. And it's because she's in this extended system where she has 8 different types of proposition. And basically what you get, how you get each of the syllogisms, is you basically say, well, these are impossible. So what you do is you say, so you take 2 of them as a premise, and the negation of the other one is the conclusion. Right? So that gives you, for example, your first choice. One of these is going to be a conclusion, so it'll actually be, so this and this, then not this. Right? So one way would be to have that be a premise, that be a premise, that be the conclusion, right? Except it'll be that, but not over it be the conclusion. That's a valid argument, right? That gives you a syllogism. The second is you can revert it because these are symmetric. You can always write CA instead of AC, right? So that gives you 2 times 2 times 2 different combinations. And then there's also, and some of these repeat, but they're also, you can replace A here with not A as long as you do it uniformly. You could have not B here and B there. You could have not C's instead of C's. They're all valid substitution instances. So, and as a result, you write out all those possible combinations, you get exactly 96 valid syllogisms. There's a good amount of work on this, which off 1999, I'll come in 2021, Cook forthcoming. I just wanted to mention that because that is the thing that Lad Franklin got celebrated for sort of around her time, up until about the 1920s, and then mention of her just kind of ceases, at least in logic. All right. Although, as I said, there's also an interesting little debate contained in these 3 papers about exactly what it is that Lad Franklin did and what outstanding problem it was that she took herself to be solving. And I'll let you read those if you're interested in that stuff. Obviously, you've got my paper, but the other 2 are in email this morning, but the other 2 are easily accessible. All right. Then we know what I call the postulate. This is really interesting. So this is added in the context where Lad Franklin wants to consider syllogisms that are valid if in fact there's existential import. Okay, which will increase the number of valid syllogisms. You don't get any of the ones with her logic right here. Every based on the formula that expresses all A's or B's doesn't imply there's any A's. Right? So we don't have existential import, just like in the modern contemporary understanding of the universal qualifier, but not in Aristotle's original. So she also wanted to cover formulas with the extended class of syllogisms that are valid if in fact you take the universal claims to have existential import, right? So all A is B implies that some A is B. To do that, she needed an additional axiom. She calls it a postulate, right? Because it's not one of the basic axioms, it's one you can add for that purpose. But here's something interesting that she says. Diminished statement, and that particular form of diminished statement, which is syllogism, are the only reasoning processes that are valid when a universe which contains nothing is included amongst possible universes. That is, when it is taken as possible that both X and not X may be at the same time existent. When that universe is excluded, when the postulate N and not X cannot both be non-existent, is taken as true, one other form of reasoning is possible. That's one additional principle to add to the system. Anywhere, unless you're doing Aristotelian syllogisms without existential import, right? Remember that? That's the only reasoning processes. That's what this diminished stuff is referring to. And it's this principle. It's impossible that there are no X's in the domain and there are no non-X's in the domain. Okay. Now that was introduced from motivationally purely to just put in the existential import so we could get the extended sort of modern analysis of the syllogisms that are valid if we have existential import. So we get the ones Aristotle liked, which is equivalent to the two inferences. If X does not exist, then non-X does exist. Because notice, it's an inference, right? It's an argument that if this is the premise and that's the negation of the conclusion, or that could be the premise, and then that without the negation would be the conclusion, given how she suggested we represent valid arguments. If X does not exist, then non-X does exist, and if non-X does not exist, then X does exist, or from the total non-existence of any expression whatsoever, maybe infer the existence of some part of it, at least of its negative. Then there's this bit that kind of confuses me a little bit. The rule, well, I'm not going to, I'll just say it. For the proposition A and B is empty or impossible, right? Or there's no situation in our domain where A and B at the same time follows in this way, it's possible that not A and B. This looks like a rule of inference, right? Which you can sometimes get one from the other in Ladd-Franklin system, but not always. So I want to look at this a little more closely. Actually, I say we're going to call this principle an uniform postulate. We're only going to use the axiomatic, what we did. Generalizing tentatively, this is interesting. The nearly uncommented on transformation of a postulate into a rule strongly suggests the following more general pattern of reason. If A and B, if A and B are impossible and A, then not B. Or maybe this like richer version, which we used in the syntax of the previous slides a bit more. If it's impossible, then A is impossible, and B is impossible, and A is impossible, and B is possible. I haven't given you the translation manual yet, but that looks something like this. If we were to translate this, it would come out as if it's possible that phi or it's possible that psi and not phi is a theorem, then phi is not a theorem, which is kind of a weird little like consistency principle. So this deserves a whole lot more thought. I'm not going to do that today, right? I'm trying to keep into time, right?
Yeah.
So now let's talk about varying domains and logical possibilities. This is something I'm arguing like hinting at throughout the whole thing. The symbol, so this is reacknowledged. The symbol infinity represents the universe of discourse. It may be the universe of conceivable things, or of actual things, or of any limited portion of either. It may include non-Euclidean n-dimensional space, or it may be limited to the surface of the Earth, or to the field of a microscope. It may exclude things and be restricted to qualities, or it may be made coextensive with fictions of any kind. Right? In any proposition of formal logic, and here I think she means giving an account of validities, the universe represents what is logically possible. Right? In a material proposition, I think, however, it represents what actually exists, and then she refers to this ID back here. First, I'm not at the time yet to go and like look at the relevant bits first to see exactly what she's referring to here. The symbol of 0 is the negative of the symbol infinity. It denotes either what is logically impossible or what is non-existent in any actual universe with any degree of limitations, right? And that kind of implies that these other universes are just limitations of the maximal domain of the logically possible. Okay. Here's some, and obviously I emphasize the really cool stuff. If A is a proposition, then A, B line states that the proposition is not true in the universe of discourse. For several propositions, A, B, C, V line means that they are not all at the same time true. This is all so far okay and pretty straightforward. And the way in which they're stated to be not all at the same time true depends on the character of the universe. If it be the universe of the logically possible, then P1, P2, line C, V line states that P1 and P2 may be taken as the premises and C as the conclusion of a valid syllogism. Okay. So far, so good. So here's what I've taken from this. So there's more texts that I can bring in, but again, I want to keep it really straightforward. Unlike other theorists in the algebraic tradition, Lad Franklin's logic is not systematically ambiguous, describing operations on predicates on one reading and logical operations on propositions on another. Rather, her simple terms A, B, C are always predicates, right, in loose sense. And logical constructions are, depending on their form, either complex predicates or propositions about the extensions of those predicates, if they have an identity symbol or a V or a V line. Now, Lad Franklin can still do propositional logic and sort of predicate logic in the system, right? But she achieved these different interpretations instead by varying the domain over which these predicates range. Domains of objects for the ordinary predicate reading, for example, in the applications to Aristotelian reasoning, at least the simple terms, just pick out collections from the domain of objects. Domains of possibilities, I think that's clear from the previous slides, in the propositional reading, right? The domain is just all the possibilities, right? We would say possible worlds, but that's, even as loose as I'm being about a little bit of this, because I'm just trying to get into the technical details, that's probably too anachronistic. But the domain of possibilities. Okay. Now, as we've already noted from the previous slide, one such domain of possibilities is the domain of all that is logically possible. That's the one I'm going to concentrate on. Right? We're going to look at Lad Franklin's logic as a logic that basically is a logic of absolute necessity, right? Where we just got all logical necessity, all the logical possibilities out there. For this domain, V line is a genuine logical impossibility operator. And V without the line is a genuine logical possibility operator, right? By the way, this is something I flagged earlier that I can now make explicit. Given the interdefinability, and this is, I think, the answer, partial answer to your question. Given the interdefinability of V line and identity discussed above, this means that on this domain, right, and any sort of modal domain, but particularly this one, identity is really necessarily identical or necessarily equivalent or something like that. Right, because just to go back, remember, let's skip it. No. Oh, maybe I did skip it. Correct. Remember, this is clearly on this domain. That kind of necessity operator. It's a possibility operator. But then that means necessity of modal claim too, if they're the same claim, right? It's necessary identity here, genuine impossibility there. Okay. Okay. And the obvious question to ask is, what modal logic do we obtain on this reading of Lad Franklin's logic? Okay, so that's the next task, a translation manual. So we're assuming, at the front end of the translation manual, we've got some relatively standard propositional language with countless many propositional letters, which we are going to take syntactically at least to be identical to the term letters in Lad Franklin's logic. So we're just going to translate those sort of holophonically, right? Conjunction, disjunction, negation, the box, which of course diamond is definable in terms of the box, and a turnstile. All right, we're going to consider arguments with finitely many premises because we're turning arguments into single formulas in Lad Franklin's logic. Given an argument in this language, so some standard contemporary argument in modal logic, the translation of that argument is first, we're going to take advantage of that place where Lad Franklin said the turnstile can be expressed in terms of V line plus a negation over the conclusion. So the first thing to translate this into Lad Franklin's logic is to just put V line there, here are all the premises, then write a line over the conclusion. Except we then need to apply our translation manual to each of these individually. But the translation manual is not at all surprising, right? So if we want to translate box slide, we just say, well, it's impossible that it not. And then we recursively apply the translation to plot. Negation just becomes the line, and this becomes, concatenation, or just becomes the plus. So it's exactly what you'd expect. Right, exactly, just straightforwardly based on the things Lad Franklin explicitly says about the stuff. We're going to treat the conditional as a defined notion, just as not fire side. I do want to note that we're treating the box and the turnstile as they're not quite synonymous, but they're expressing the same notion of necessity, right? But that really isn't worrisome, right? There are people who think about, for example, S5 in particular on the logical necessity reading as doing just this. The box captures the notion of necessity that is exactly the logical notion of necessity. This is the same one that's being expressed as a many place operator by the turnstile, right? So that's kind of what's going on here if you're worried about that. Now let's look at the axioms and rules. So let's look at the modus ponens, the axiomatic form of modus ponens. So here's the axiom, right? A phi and phi arrow psi, then psi. All right, first of all, we got to get rid of the conditionals, so we rewrite it in terms of nots, ands, and ors. That's its translation based on the translation manual. Now we just go through doing a bunch of substitutions based on the various axioms and identities she gives us, and we end up with that being equivalent to 0 equals 0, which is clearly a tautology in Lad Franklin's system. The other key things worth noting is the double negation has to be derived. She never does, but it's very easy to derive from the principles she has. That's, I think, in my paper, the other paper, but I didn't do it on the slide just to save some space. And here, this is something she doesn't explicitly say, but it's pretty clear from the things she does that 0 plus 0 is 0 in the system, right? If it's in the empty collection, or the union of the empty collection and the empty collection is the empty collection, right? All right. What about the rules? That if this holds and this holds, then this holds. Well, here's the translation. If that's a theorem, and that's a theorem for some phi inside, then that better be a theorem. First thing I did is simplify this one a little bit, right? Because remember that negation there is really shorthand for negation over the whole thing where we have just to be there, but then we can use the double negation to get rid of those. So simplify it a little bit, just syntactically. And then we have the derivation. By the way, if we want to come back to these in question and answers, like go through them step by step, we can. I am not going to spend the time right now going through these, but we basically, I have it listed, but we're just using the identities again and the substitutions. Right? So, and we eventually, if we have these two, then lo and behold, by that substitutions and various manipulation, we can get the conclusion is also a theorem. How about the K axiom, since we're doing modal logic? All right, well, here's the K axiom. Right? So necessarily phi, necessarily phi or psi, then necessarily psi. Again, get rid of conditionals. That's the translation. A bunch of the substitutions and rearrangements. And we get that it's just reducible to a special one of our axioms. Okay. How about, and this is the really interesting one, how about axiom D? Right, so again, I mean, we would probably, in colloquial terms, write this, it's necessarily phi and possibly phi. Rewriting this without conditional, we get this, that's the translation, right? Double negation, 21, another double negation. That's the postulate. Right, so Lad Franklin's system, that additional principle that she said that we could add to get rid of like the empty universe, the empty possibility, so that we could, represent existential import, right? Also gives us the D axiom in Christine Lad Franklin's system. How about what's been called in the sort of in the C.I. Lewis systems, the consistency postulate, which if you don't have other stuff in some of the weaker like S1 and S2, turns out to be interesting and non-redundant. That if phi inside is possible, then phi on its own is possible. Well, yeah, there we go. Oh, and by the way, that's the strict implication, right? So notice first we got to get the box there, and we do a bunch of work to simplify it, but that is not the material condition, right? That's why we get that box up front. We put that as material conditional, right? The consistency postulate. Oh, well, once we have that, that's its translation, right? Boom, 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 and we just go one of our axioms. That's pretty cool. How about necessitation? Well, again, I already told you I don't have like a completeness theorem yet for the stuff I do have. As far as I can tell, there's no derivation of necessitation. That if phi is a theorem, then necessarily phi is a theorem. Or, in Christine Lad Franklin's, we're getting from this to this. There aren't any sort of like principles that easily allow you to jump levels from like something that is a single modality to two modalities or vice versa. We could derive necessitation in its converse if we assumed or added this somewhat plausible looking principle. Right? Impossible phi, then phi equals zero, then it's not the case that phi equals 0 is impossible. Right? But notice, remember, that has a modality built in, so we're almost kind of begging the question. Right? It's plausible looking, but it's not there. Here's the sort of derivation of the identities real quick without the citations, but this also involves something else very weird. It involves, this is the proof, and I can't find a way to do it without doing this, involves, and even the principle we would think about adding to get necessitation, would involve a negation over an identity. There's nothing in the rules that say you can't do that, but it's striking that throughout the entire, like 60 pages, 80 pages, whatever this thing is, dissertation, there's never a single instance of an identity with a negation over it. That may just be a stylistic thing or a, aesthetic thing on Lad Franklin's part, but I thought it was something worth mentioning since we're already like considering cheating here, right, to get what we want. So we don't get necessitation. That's fine. Some of Lewis's systems didn't have necessitation. All right, so that's what we get so far, right? Which is pretty impressive. So here's some final thoughts. How am I doing on time? Good? Okay. So you go and pull out the origins of contemporary modal logic SEP article, which I spent a lot of time. And we've done standard story, which I knew this far, right? C.I. Lewis is often credited with the origins of contemporary modal logic. And by this we mean some sort of like post-Frege axiomatic system, it obviously evolved into the S4s and while in some of these S systems were his, it evolved into the modal logic systems and the sort of work that we know and love, right? First of all, I think one thing that's worth flagging is that Lewis's motivations were not the kind of motivations that most of us have when we're just sort of standardly working with modal logics. Right? Lewis was not particularly primitively interested in modality. Right? Lewis was a proto-relevance logician. He was worried about the conditional. That's what Lewis was up to, and he used these modal notions to build better conditions. Okay. That's just something I think is worth noting. Contrasting that, Lad Franklin, on the other hand, looks like she was clearly motivated by sorting out how necessity and possibility work. Right? So her motivations are closer to the motivations we have when we do, go and teach a class on modal logic or do modal logic. Right? We're interested in the box and the diamond, not the arrows you can get out of those. Right? Another interesting thing to point out is Lewis was, according to the SCP, I have not done this work myself for Lewis, likely deeply influenced by McCall's work on potential conditionals. Okay. The next thing on my list of to do, and this is you mentioned you have spent some time with it, is to go and print out all McCall's stuff and spend some months just reading it over and over and over again until I really understand what's going on there. As well as some secondary literature, obviously. One thing that's clear, and that Yasmin and I have been talking about a lot, but neither of us have gotten to do the work. Lad Franklin mentions McCall in her dissertation more than anyone else, including Peirce. It is clear that McCall had a huge influence on Lad Franklin. Right, so that's another interesting sort of connection, just something worth noting. All right, so that's some historical stuff. And now let's look carefully at the systems proposed by these theorists. Now, notice, we are doing something a little anachronistic here, and this goes back to something Jillian asked me earlier, right? Whatever happens, we're not going to be able to, in real sense, to claim that Christine Lad Franklin gave us S2 or something like that, right? Because she's working in a very different context, 50 years earlier, right? 30 to 40 years earlier. And obviously didn't have Frege, right? Didn't have the kind of axiomatic approach to logic that would come later that Lewis was able to take advantage of. I mean, she writes the stuff as looks in terms of the presentation, and it's more computational than proof theoretic in a certain sense. So it's a very different kind of system, right? So when I say, did she invent it or discover it, obviously there have to be some caveats about sort of what was available and how the stuff was done in her time more generally versus what Lewis was doing. And I just want to flag, I'm aware of all that. Okay. But nevertheless, when we have these translations, we can sort of take her things and sort of convert them into modern looking things or Lewis era looking things. So let's look at Lewis's system. So S1, the weakest system, other than the original one which he gave, which was trivial, or in the sense that the modality just collapses into nothing. We have a bunch of these are just necessitated versions of valid propositional. This is the strict conditional, right? So it's like necessarily A or B. Loosely speaking, so we have, we can rearrange ands, and elimination, loosely speaking, in axiomatic forms of these. But most of this is pretty straightforward. This, however, is where things start to get actually interesting, right? So if loosely speaking, necessarily P1 entails P2. So necessarily, right? That's where that necessarily, if necessarily P1 entails P2 and necessarily P2 entails P3, then necessarily P1 entails P3. And then we have something like necessarily P1 and necessarily P1 entails P2, then P2. We have uniform substitution, which is very obviously in Lab Franklin system because she just gives us these identities and starts doing substitutions. Substitution of strict equivalence, right? So if necessarily phi 1, if and only phi 2, then we can replace those. Adjunction, basically that's just an and, literally the and introduction rule. And strict inference, if phi is a theorem and that's a theorem, then phi 2 is a theorem. Okay, but notice that's the strict conditional, that's really necessarily phi 1, material conditional phi 2. All right, X2 we get, this is why I was interested in the consistency principle earlier. X1 plus the consistency postulate, right? Okay, I'm not gonna bother with all three, it's got some additional stuff in it. I will mention it real briefly, but I didn't list it. Now let's look at the system I'm gonna call LF, which is the contemporary looking system we get by looking at Lab Franklin's system and applying the translation manual backwards, say. All right, so what do we get? Well, on this one, we get everything but at B7. Because notice this we get because that is just a necessitated version of axiom, right? Further, we get uniform substitution, substitution of strict equivalence, and adjunction. I didn't bother to prove adjunction, but you get it. So we get all of these. We do not get strict not strict inference. Both tones in both the axiomatic and rule form. The consistency postulate. So we get this. We get one of the principles from S2, right? And we get the D axiom. Now, so this is not even a subsystem. Sorry, a supersystem of S1. Right? They're incomparable. S1 has stuff it doesn't have. It has stuff S1 doesn't have. But it's not even because of the presence of. So it's not a supersystem of even S1, but it's a relatively powerful and interesting modal logic, right? And it's also notably not even a subsystem of S3 because of the presence of the D axiom, right? Also, this was mere speculation. We've also seen a way to extend the system so that it's equivalent, a natural way. It's not in Lab Franklin, but it was a natural way to extend the system, that speculative slide with that extra axiom, so that we boost it all the way up, just with that one addition, to the modal logic D. Now, is that anywhere close to what we think the modal logic, or at least the standard answer for the modal logic of logical necessity is? No, most people, if they think there's an answer to that, think it's S5. But nevertheless, that's a powerful system. However, all of this was about a good 29 years before C.I. Lewis first published on modal logic, at least the standard stuff that's cited, and a good 49 years before Lewis thought he got it right. Before Lewis's views sort of settled. Okay? One other thing that's just kind of cool and impressive that I want to mention, it's also perhaps worth mentioning that Lab Franklin was concerned with formalizing consequence, right? Premise conclusion arguments, right? Whereas formal logic consistently, almost uniformly, was formulated in terms of theorem systems until well into the 20th century, right? The idea that logic is about blah, 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 turnstile, blah, 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 rather than just being about turnstile, blah, 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 is a relatively recent thing, right? So that's kind of interesting. And so I think all of this, and this is like the more like even-handed version of the title of the talk, this at minimum suggests a serious reappraisal of the standard history of the development of modal logic, right? Now, of course, the sad thing, and one of the reasons why this makes this sort of project of feminist interest, is where we are today is due to Lewis, right? This stuff, this reading of Lab Franklin stuff, I think had zero impact on anybody, right? So it's not where our stuff came from, but there is a counterfactual story about where people weren't evil, where our modal logic could have come from. And could have come from this stuff and have come a lot earlier. Right, these initial like developments in this direction. So the whole is Christine Ladd Franklin was rap. So that is the talk, and there are the references.
So thank you, and I will say this is impressive because you.
Perfect on the dot.
Yeah.
Nice.
You did this on the dot, and we have 20 minutes for the Q&A.
Plus years over email, so it's okay.
Yeah, and so don't get angry if you raise your hand and I don't acknowledge it right away because I'm giving preference to students and women. And if you're unsure of how to phrase your question in English, well, we can always help translate, okay? So, Jillian.
This is super cool, super interesting. Yeah, obviously this is a huge part of the history of modal logic, and I've never heard this before. One sort of like clarificatory question, or at least sort of connecting it up to other things. This like idea that modal logic was conceived in sin, which is probably fine, right?
Yeah.
And the sin is like use mention confusion. Is that also going on here? Like when we had the definition of the B-line operator, it looked like it was like, I mean, it looks like, yeah, like you said, like logical consequence, right?
Yeah.
So now that looks like a meta-linguistic thing, but it's sort of being used as a in the language operator. Like, it'd be really interesting if like this other like independent conception of modal logic was conceived of the same thing.
Yeah, I'll get to it. I'm gonna give a little bit of snarky answers to that, and then a bit of a serious answer too. I mean, first of all, everybody was as sloppy about use mention in this period, right? So, I mean, I think Quine's worries about the use mention stuff are different because he's like, even if you formulate it correctly, the box is really the right understanding of the box is expressing something about sentences, not something about stuff, right? Whereas, I mean, the joke, I love this one. I actually used this quoted this in the preface of my book called The Omelet Paradox. I live a line from Hartree Field, and I'll apply to Christine Ladd Franklin. At this period in time, Christine Ladd Franklin, Frege, I think Frege was a little bit better by Grungesetz. Grungesetz is actually pretty good use mention lines, but earlier Frege isn't. Russell and Whitehead is a disaster, right? But Hartree Field in his book On Truth has this great line where in the preface he says, at the end, he says, throughout this book, I adopted the use mention conventions of Principia Mathematica. Because sometimes it doesn't matter and the quotes just look silly and cluttery, right? And people know exactly what you mean. Sometimes it doesn't matter, right? And you want to make sure you're getting it straight. Sometimes it doesn't. And so I think probably what's going on here, and worth checking and really going through carefully and thinking about it. I'll admit I haven't done that. But my suspicion is this is just Principia Mathematica style sloppiness, not sort of deep Quine style worries about what she actually has in mind is sort of is facts about language rather than facts about the world sort of worries, which I think is what Quine was up to with those sorts of those concerns.
Okay, so I have accent from Thomas. Any other questions? You can wait, sorry.
So I'll go first.
And then you have like 5 questions surely, so you can go to the end. So Thomas.
Thank you. That was really awesome. Can I ask you to go back like 3 slides to the characterization of S1? So can you give an idea about like in like Ladd Franklin terms why strict inference would fail? Like, is there kind of a story in?
Yeah, it has to do with the jumping levels and the fact that that's strict conditional, right? So the first one is just it's phi the theorem and then phi aside with the strict conditional. So it's like look at something like this, right? Which becomes, and then we have, let's go write it this way. Becomes configured marker. Yeah. Is.
I think the red one, the
Red
red
one on your
marker
notes is pretty
works, yeah. very well.
Oh, should I write in the red real quick? Red one's dying too.
Okay, so we have working markers.
I was gonna start over. Oh, oh wait, it's a theorem, isn't it? It's not a, it's a rule. I'm doing the thing at the bottom, which is the same.
Oh, yeah, I was thinking
Yeah,
the bottom.
yeah, the bottom will inverse will work. It's the same problem. And you know, slightly different formulas with the same problem. And the problem is Glad Franklin doesn't have good rules for getting, like, unpacking the content of this, right? The rules really, like, some call it singly modal or call this doubly modal. She doesn't have good rules for getting, for interactions between things of different modal levels in that sense.
So I guess what I'm curious about is if I'd been back in 1883 and I used your paid attention, I sometimes, yeah, and I used the latter.
I was not talking about you, that was comments about men in general.
Okay. But specifically it works for me too. Yeah, okay, so suppose and I said I pointed out this bottom version of it and I said, can you explain why this wouldn't work? Is there like a narrative for how I can motivate the failure of this?
No, I think it's an oversight, because I think Glad Franklin never, she has some shorter articles later where she defends, like she corrects people who misunderstand the Aristotelian characterization part. She'll mention the varying domain stuff, but she never develops this stuff extensively, so I really think it's an oversight. I really think if we did the what should Glad Franklin have done in a part, or what would she have done if she'd gotten hired and had all sorts of people back and forthing on this stuff and given talks, probably eventually somebody would have said, what about this? And how do you get this in the rules that would work and figured out you couldn't and add it in principle? I think it's an oversight.
Okay, so then it follows from some picture of the domains that she's considering.
Actually, that's part of what I'm hoping is that if there is a genuine semantics to be sort of extrapolated from the stuff at the end, that semantics will support something like this where we can say, well, look, she had this sort of intuitive picture of how it's working. She gave some axioms, but she didn't see that she hadn't given enough axioms to get what she wanted. That's the story I'm predicting, if all goes well and how I hope, that I will be telling about this, but I have not done that work yet.
Cool, thank you.
Okay, okay.
Yeah, this is great indeed. But you claim that there is no ambiguity between the predicate and the propositional. But okay, so here's why I don't see it, because in the definition she gives of identity, it is between predicates, right? That is why it's equivalent to. But then in the definition she gives of the incompatibility, she says proposition. And they are, and as you rightly point out, there is this Galois connection that makes them. Yeah. So how can this be like a relation between proper?
I think propositions are just predicates that hold. I mean, I think there's a very modern view for her. I think for her, propositions are. She doesn't quite out where it says this, but you can sort of piece it together from the other bits. Propositions are predicates that hold of possibilities or situations, depending on exactly how constrained your domain is. I think just like we in some modern systems, we think of propositions as sets of worlds. She thinks a proposition are predicates that hold of possibilities.
But then doesn't it make trivial the idea that there is a then there is no distinction?
Yeah, then I mean, so that's another way to say it. Distinction is because she has one interpret. So she has one interpretation. I mean, it's a better way, maybe a better way of putting it. She has one interpretation. It's all the predicate reading. But she achieves what other theorists have achieved with the propositional, with the other reading, the propositional reading, by treating showing how you can treat propositions as a special case of the predicate reading. That's a better way of putting it. Yeah. Does that help?
Yes.
Okay.
Okay. Anyone else? Well, you don't make your question then.
No, thanks, that was great. And as I see things, that frankly results in the business of dealing with this implication, entailments, consequence thing, just as Lewis and many of his contemporaries. And I can see that it's great to have the focus on the model notions. But I think there is also a very important notion that was understood completely different by Lewis, and he won the battle, so to speak. And it is the notion of exclusion and inconsistency, because at the time of Lewis, there was this debate about how to understand implication, either in terms of impossibility, and there was the Nelsonian camp in trying to understand this in terms of inconsistency, in the sense of incompatibility, as Einstein said. Inconsistency now means something different, and I think the notion of exclusion was lost at some point in the 20th century to give preference to the notion of consistency. And I was wondering if you have tracked this notion as you have it with the modalities, or do you have any suggestions?
Not in any way. Part of this, I mean, there are these two dames because I'm not a historian of logic, right? I mean, I've done some Frege stuff, but that's it. I'm sorry, a little bit about Frege and what was going on with him. And the two people I clearly need to learn more about the history of and the debate surrounding. One I already mentioned is Hugh McCall. I think that's going to be huge, right? The other is Lewis. I know of these debates, but I don't know a lot about them. With the McCall, since Yasmin Ozil happens to be a specialist in the history of 19th century logic, convenient, right? That's kind of how we're looking at our collaboration, is I'm sort of doing the more technical stuff. I mean, we're obviously going to trade back and forth, but like the beauty of the collaboration is I've got the technical stuff covered, not that I can't do some history too. She's got the historical end covered, not that she can't do technical stuff too, but like a sort of nice combination of skill sets. I'm planning on digging into all that stuff, but I also, even then, probably won't feel confident saying a lot about some of these historical nuances with these debates without sort of her approval. Given it's a collaborative project, I wish brought her along. And I don't have an answer really, but I mean, that is one striking thing that I didn't really bring into this, and this is really helpful though, because I emphasized earlier, like for her logic in general, she really emphasizes the crucial foundational idea is consistency and inconsistency. And then you build everything up out of that. But I hadn't even to the superficial extent that I know about those debates, and at the moment it's still pretty superficial, hence all the extra reading I gotta do. I hadn't thought to connect that to the later debates that you were just mentioning. So I don't have anything super insightful to say, but that question was really helpful in terms of like connections that I hadn't quite seen yet. So thank you. Yeah.
Okay, so Thomas has another question.
I too, but I've got another question. Who's the resource?
I think, I had a question.
You told you said you have a question. Oh, you mean you had questions in the? Oh, I thought you.
Yeah, I don't think I may have.
No pressure. You don't have it.
Yeah.
I'm sorry.
I may have comments for the questions. So, okay, yeah, you're okay.
Sure.
Even for two questions, yeah, sure. I mean, I
But
think.
Jillian did just have a hand.
Oh, sorry.
So maybe one, and
Thanks
then,
for the questions.
yeah, maybe one, and then Jillian, and then we can go back to.
I'll make a comment about what Luisa said. You mentioned, my ears kind of perked up when you mentioned Lewis's motivations, because in a couple of the Lewis items, he introduces first a calculus of consistencies as the primitive. It's a study of consistency between propositions, and then as an auxiliary to that, now let's look at implication. So like Lewis expressly is concerned with consistency first, and then as a subordinate thing, now we can go and investigate implication.
I did not know/remember. I mean, I looked at some of that stuff long ago. That's why I said it's explicitly on my tasks to-do list is to dig into that stuff. Well, but that's helpful, yeah. So I mean, obviously I gotta go and just read all the Lewis, all secondary literature about that stuff. I mean, everything I said about Lewis came out of the SCP article, to be honest. And all this stuff is just copied explicitly from the SCP article in terms of, given the time I've spent digging through just hours and hours and hours and hours and hours with just the one. I didn't look super carefully at the other publications. I've read them, right? Just because it's been so much work to get straight on what Christine Franklin is doing, just like at a primitive level of understanding the system, that I haven't yet gotten to a lot of the secondary or connected stuff that I want to. So yeah, everything that I say with authority about Lewis on these slides is straight from the SCP article on the origins of contemporary modal logic. Go ahead.
It's just something I'm wondering about and don't get. I'm wondering if you get it better than I do. So if you're like starting out on modal logic, I feel like the most intuitive, the easiest thing is not the D axiom, it's the D.
Yeah, that's, and there's no way I should have probably had a slide about this, but I was already up to 45 slides. I haven't seen a way to get to it, right? And that's weird, right? And to be honest, and again, I mean, one of the things is a lot of this work is going to be speculative, right? Because compared to the impressive male logicians who got jobs and gave talks and wrote lots of follow-up papers and books and also, Franklin never got that opportunity. So we have much less data to work with. So we have to, instead of seeing what they did and how they further developed it, with Franklin, we have to sort of guess, well, what would she have done if she hadn't become like an amazing color vision psychologist, right? And because I think the D axiom, as cool as it is, and it's part of the system, and I mean, kind of, it's like this thing we add, except for when we're doing, weird Aristotelian stuff, it's still an official part of the system. But the fact that it gives us D looks accidental, right? I mean, this goes back also to Thomas's point about, what about an inference like this? And my suspicion is that that's an oversight. On the modal reading, there's all this cool stuff that she probably, had she been pressed or asked or pointed out, in a different, different history, she would have played with and added and extended the system, and maybe said, I got D, or she wouldn't have called D obviously at the time, but I've got this principle. But actually, I think I want the stronger T principle. What do I do to get even that, right? What do I get stronger? But that just never happened, right? So my suspicion is she had, in terms of the modal reading, because she never really proves any theorem, she never does any of the kind of stuff I'm doing, proves these where there are particular modal readings that she wants to get, right? All that's me, filling in from the description of the modal reading and then saying, okay, well, what do we get in the logic? My suspicion is there's a lot of randomness and oversight here on the modal reading. And D was an accident, right? We get D because of something she observed about the sort of standard predicate reading where you're doing the Aristotelian stuff and you might on a certain kind of reading of the syllogism want this extra principle that just happens out of logical luck, if that's kind of thing, to have given us this cool principle D that we know about. And she would have probably wanted to, right? But unless that one thing that I said I haven't figured out how to use usefully yet gives us T, which that would be awesome. And I can't say I know it won't, but I'm not super optimistic. I think it's like some of these higher level things that look really cool are kind of random because they're coming from other concerns for the system, but they just happen to give us some, but not all of the cool stuff we would want in a logic of logical necessity. So yeah, so I agree, D is weird, right? But I don't think she was motivated by D as a modal axiom at all. I think it was because it happens to be the translate of something else on a different domain that she was interested in.
Okay, so Thomas, can you get your final question like in 2 minutes?
I can give it in 15 seconds.
Okay, we'll see.
You showed that LF, your system LF, that it maps into Lab Franklin system. Does it work the other way around? Are they equivalent?
No, I have no idea. I suspect that Lab Franklin system, like I said, I've just been playing with this. The hope is that I can give a formal semantics based on the sort of informal discussion of semantics at the end, and then probably one of them gives an English theorem. I suspect the semantics will support things like this, and certainly like T. So the Lab Franklin proof system, I think, is, well, certainly what I've given here is almost certainly weaker than what you can prove, right? I'm just trying to prove some cool stuff to convince you it's interesting. But I'm hoping that semantics or something like it will allow me to say this is exactly what you can prove by some kind of completeness theorem, but I have not come anywhere close to doing that work yet. but that's the hope. Is like, but my suspicion is, yeah, I basically, this is just meant to be, yeah, to put it carefully, if LF is the system that Lad Franklin gives in the dissertation, this claim is just that it contains all of this, right? Not that it is exactly this. I suspect there's more you can get beyond this, but I haven't gotten that result yet.
Okay, cool. Thank you.
Okay, then, I guess I can declare this workshop officially concluded, and let's, thank you again.
And once again, let's thank the organizers and the attendees and just everybody for like this super cool event.